Hi, yes, good afternoon, Amsterdam. I'm delighted to be back here. I love Amsterdam. I am here this afternoon to talk to you about how we talk to each other. This talk is about the theory of communication, how language functions, and how we can get better at it to make our lives easier as people who talk to other people, as people who talk to computers, stakeholders, as we are builders and designers and maintainers of software. So there are lots of ways that communication can go wrong, and the results can range from anything like from my code is buggy, my code is wrong, to you have a request come in from a stakeholder that means you have to rewrite your system from scratch. Has anyone ever had that where you've had a product manager or somebody say, we need to do something with our software that makes complete sense in the real world, like your user needs to be able to change their gender marker or something. And you go, well, that we just would have to rebuild the system from scratch. That's immutable. We can't do that. Has anyone ever had something, a situation that reminds them of? Yeah. That's a failure of communication, and I'm going to explain how, and how we can hopefully avoid those kind of very expensive mistakes in the future. So what I think is happening when we talk to each other is this. There's two people, me and you, let's say, and I have an idea in my head that I want to communicate to you. And as a result of this idea that I have, I say something or do something. I say words, I type things, maybe I make a gesture. And as a result of that communication, that effort of communication, you perceive something. You hear language, you read words, you see a gesture that I've made. These two things are not necessarily the same. I might stumble over my words. There are many ways to interpret words. And as a result of what you perceive, you have an idea in your head. This is the basic model of communication that I'll be referencing throughout this talk. And it can be more complicated than this, of course. That process of communicating from me to you might involve encoding language into JSON and sending it over the web, or any number of different ways of encoding and transmitting data. We won't be getting into that today. We're going to really focus on this very simplified model of I have an idea, I try to communicate it, you perceive something as a result of my attempts at communication, and then you have an idea in your head. Something I really like about this model is obviously there's a sort of translation layer between what I say and what you hear, particularly if we're translating between different human languages. But there are translation layers also internally within each of us. What I have in my head is not actually the same thing as the words that I say. Those are two separate things, and there's a translation going on there. We have two separate things going on inside us. When we try and communicate, we have an idea, and we have the way in which we try and communicate this idea. Now, we have our first philosopher of the day, and he basically founded a lot of modern linguistics, Ferdinand de Saussure. And the thing that he did today that we're particularly interested in is that he invented the field of semiotics. He's one of the sort of founders of this field called semiotics. And semiotics, well, he called it semiology, is the study of signs. This can mean things, visual signs, so something like road signage, all kinds of advertising. There's loads of semiotics in advertising and marketing. But signs are more broad than that. Words are also signs. A sign is anything that you use in order to try and communicate. And what Saussure said that was revolutionary for his time is that he took these two separate things, your idea and the way you try to communicate it. And he said these are both components of a sign. And he called the idea the signified thing, the thing that is signified when you try and communicate. And he said that the thing that you say or do as a result of that concept is the signifier. Now, in the interests of me not stumbling over my words and making these two things much more, drawing a contrast between them, I'm not going to say signified, I'm going to say concept, because that's much more audibly distinct from signifier. And what Saussure said that was really groundbreaking for his time was that these two things, these two things don't intrinsically have anything to do with each other. At the time, people thought that there was some kind of deep, like mystical almost, connection between ideas in our heads and the sounds we use to describe those ideas. But Saussure said, no, they don't actually intrinsically have to have anything to do with each other. For example, this animal In Egyptian, it's called a mao. And if you've ever met one of these animals, you'll see why that's the case, right? But in English, we call it a cat. And it's not actually so obvious why we should. Cat and that animal, that's just a series of sounds that we've decided refers to this concept. It goes more further than this. It gets even more complicated or complex. We can have very complex meanings associated with things that are not actually necessarily intrinsically related, and memes are a great example of this. You know, why does this guy here disappearing into a hedge mean like, oh God, that's awkward, I don't want to be a part of it? Because we've said it does. And we can have signs and concepts that don't necessarily have anything obvious to do with each other, but they actually are linked through our usage of language. In shorter summary than this, you know, we can communicate concepts using signifiers that are not actually anything to do with the signs in our heads. Or rather, what does it mean that it has something to do with the signs in our heads, the concepts in our heads? So if we come back to this diagram where we say, okay, I've got an idea and I'm doing something, I have a concept in my head, and I'm using signifiers to try and communicate it to you. And you hear something, and that is a signifier that you've perceived, and it creates a concept in your head. We come back to the idea that there's this translation layer in between the concepts in our head and the things that we try and use to signify those concepts. If there's a translation going on, what's the dictionary? How can we understand the relationship between ideas and signs? Another thing that's that this diagram also that I like, I'll go back to the colourful version. Pink light bulb, blue light bulb, they're not the same thing. We can never actually know because of these translation layers that we have internally. We can never know that what's in my head is the same as what's in your head when I'm finished giving this talk. You can't compare them because of this personal, incommunicable translation layer, right? But I don't think this translation layer is actually incommunicable. We can study it, and this is what Saussure was doing when he said, okay, we've got these signs and concepts. If we think about incommunicable words or incommunicable concepts, I first gave this talk in Portugal. Do we have anyone Portuguese here in the audience? Would you like to try and give me a translation of this word? No, you would not, right? It's a word that's commonly described as untranslatable. And part of the reason for this, and we'll come back to this later, is that you might say that it's an idea, a concept that some people can have and others can't because of its cultural context. And therefore the signifier, this word that's used to communicate that concept, doesn't actually necessarily make sense to other people because they have no internal concept to map it to. Now, if we have this relationship between concepts in our heads and signifiers that we use to communicate them, if they don't necessarily have anything to do with each other, how can we even communicate? How do we know which signifiers to use? What's that relationship? Saussure had an answer for this too. He said, when somebody talks, there's a person with an idea in their head, and they say and do something as a result of that idea, and this is called parole, an act of speech. He was French, he had French words. This is an act of speech, an instance of communication. And people are able to make these, to instantiate communication like this because they have some idea of a language. And the language is what gives us the translation between concepts and signifiers. And he called this the langue. And these are the two components of speech. You need to have an idea of the langue in order to be able to make parole. But what Saussure said that was also, again, revolutionary for his time, people hadn't really quite articulated this before, is that acts of speech circle right back around and influence the external langue. When you say something, you're actually contributing to this global idea that people share between them that allows them to translate between concepts and signifiers. For example, memes and slang. Why does Homer disappearing into a hedge mean, oh God, that's awkward and I don't want any part of it? Because we said so, because we used it to mean that, and it became part of the broader language. And this is what's called Saussure's speech circuit. He said, this is actually a flow. When we speak, we're informing the way that language should be spoken. So how can we understand this? This is what linguists study. And this is the thing that's of great interest to them. This kind of concept which exists outside any one person's head, but cannot exist without people, something which defines and is defined by its own usage. Well, it's time for us to meet our second philosopher of the day. This is Ludwig Wittgenstein. To me, he is like the philosopher. He did everything. Logic, ethics, mathematics and language, he did like everything. I love many of his ideas. But the thing that he did and articulated that we're interested in today is his concept of language games, for which this talk is named. Wittgenstein argued that language, like games of skill or chance or athleticism, have rules, and that in order to be understood when we make acts of speech, parole, we have to play by the rules. And any people who have a shared understanding of the rules can play a language game together. He used a lot of analogy to describe this concept because it's quite hard to articulate directly, so I will do the same. And the idea of rules being what informs language is rules give us this relationship between concepts and signifiers. So let's say we have two software engineers. Let's call them René and Thomas. And they are building some Lego together. And René is one building the Lego, and Thomas says, is in charge of the pieces. And René says, brick. And Thomas hands him one of the pieces that look like this. And then René says, plate. And Thomas hands him one of the ones that look like this. Then René says, jumper. And Thomas hands him one of the ones that look like this. They're playing a very simple, fundamental language game where the word jumper means hand me one and exactly one of the Lego pieces that look like this, right? If you said banana, wouldn't make sense. That's not a move that makes sense according to the rules of this language game. Now, it's worth noting that instead of using the actual official names of these Lego elements, René and Thomas could have said pink, white, and blue. Pink has one fewer syllable than jumper. It would have been more efficient. But they're big Lego nerds, and they like to use the official Lego terminology for these particular Lego elements. Language games aren't always efficient. The rules of language games aren't always efficient. There's always human quirks, weirdness, inefficiencies involved, because that's what people are. This is what it looks like when you break the rules of a language game. Just take this in for a moment. Does this mean anything? So this is an example of something that's called in linguistics a comparative illusion. And it's like that Escher drawing of the staircase that loops back on itself because of the perspective. Each component part of this sentence sort of makes sense, but when you look at it as a whole, it doesn't. And technically there is a grammar error in here in that you are comparing a number. You're comparing a number to a Boolean, right? You're comparing an int, people who've been to Berlin, than I have, yes or no. But it scans like English, but it doesn't make any sense. This is an example of breaking the rules of English, something that is a failure of communication. It does not communicate information. Here's another sentence. Does this make sense to anyone? This is something I say all the time in my household. And this means I need to trim the cat's claws. Right? She's the baby. She's the baby of our household. She's an indoor cat, so she isn't wearing down her claws on outside, on concrete or anything. And so sometimes she gets sharp. Her nails get too long, her claws get too long. So we need to unsharpen her. And the reason this makes sense as something for me to say within my household is that we speak English and we use the rules of English, but we have extra rules, house rules, above and beyond the rules of English. If you've ever played Monopoly, you may be familiar with some versions of house rules, like you will put your money that you pay in fines into the middle, and if someone lands on free parking, they get all that money. That's not in the official rule set. That is a house rule that people add because it makes the game more fun, because it allows them to play in a different way that's more enjoyable or useful for them. So we have this concept that there are basic rules of some broader language, like English, but you can also add rules on top of that to allow you to use language in a different way, in a more specialized way. So this is a sentence that makes sense in my household, but not many other households. Context is what sets the rules. In the context of my household, you can unsharpen a baby, but not in the wider world. And this, again, like with what Saussure was saying, was actually revolutionary at the time that Wittgenstein said it. And to me, they're almost the same thing, is that context is what gives language meaning. Context is what gives you the relationship between a concept and its signifier. And it's so obvious when we say it, but at the time, it was groundbreaking. So we come back to this word, this untranslatable word, saudade. And with the new understanding that context is what gives language its meaning, we can re-examine this word. My understanding of this word is that it refers to a certain bittersweet longing felt by wives when their husbands were off on pioneering sailing adventures. And it can also refer to the feeling of Portuguese people who had moved to Brazil and the bittersweetness of knowing that you'd left behind everything you'd ever known in pursuit of something new and brave and unknown, and the sort of fear and longing mixed with, anticipation. You please feel free to correct me if I've missed. Yep, cool, good. And the reason that this is often referred to as untranslatable, I think, is that describing that requires knowing the context of the people who had this feeling. I'm not a pioneer sailing around the world during the age of exploration. I'm not somebody moving to a new world, leaving everything I've known behind for a chance at something better. Perhaps I can never feel saudade. I can only intellectually know that this is what it's referring to. So, with that knowledge, context, setting the rules for language games, what does it look like if we're going to communicate with people that we have no context shared with? Does anyone recognize this phrase? Oh, interesting. I always think this is really widely known, but it might just be the specific kind of nerd that I am. So this is a phrase from the Institute for the Storage of Long-Term Nuclear Waste. As humans, we've created a lot of problems for ourselves with technology. And one of them is that we've done nuclear power, which is by and large a good thing, but it creates lots of waste that is going to continue to be harmful to humans for a long, long time, on the orders of 10 or 20,000 years, let's say. That's a long, long time. That is longer than any one human language lasts. Human languages come and go and evolve and fade away much faster than that. But we have created this problem, and it's going to be a problem for people in 10 or 20,000 years. We have a responsibility to warn them about it. How can we communicate this when we have no idea what their context will be? We have no idea what human languages they're going to be speaking. And that is the job of this institute that has been set up, and it has a mandate to try and figure out how we can communicate this concept. We've buried something bad here, don't dig here. And there's an extra problem there, because what do people do if you say we've buried something bad here, don't dig here? They're immediately going to go and dig it up. So that's the mandate of this institute. And I think some of what they've done is really interesting to look at in the context of the theory of communication. So this is, I've forgotten the actual ISO number and I don't have it up on screen here, but it's an image that they created. And the idea is that this is something that could be used to try and communicate, this is bad, don't dig here. And if we look at each element of this sign, we can understand why this might be expected to work. So first we've got a skull. In general, people don't see skulls in real life unless something has gone horribly wrong, right? We as humans have tended to bury our dead. Just from the earliest records we have of people, we've buried our dead. You don't tend to see actual skulls unless something catastrophic has happened. So a skull, and we can assume that people in 10, 20,000 years will have pretty similar skulls to ours. That's not long enough to do significant amounts of evolution and change the structure of our body. This could be broadly understood as a general sign of bad, no bueno. Something is wrong here. Similarly, 10 to 20,000 years in the future, we can assume that people will have a very similar body map to us. It's not enough time to get any extra legs or anything. And so this will probably be able to be parsed by people as a person, right? And a person in motion. And hopefully the arrow will still convey something similar of a person in motion towards a certain direction. The really hard bit to communicate is ionizing radiation. It's a very specific abstract concept that, how do you communicate that to somebody? Yeah, how do you? And what they've come up with is the symbol for nuclear radiation and then these sort of rays emanating from it with these arrows. And this, I think, is the part that's hardest to communicate intrinsically. And taken as a whole, there's good reason to think that this symbol might convey some of what we're trying to convey with it. However, it could also mean when snakes come out of the ceiling fan, run away from the pirates. Signs and signifiers and concepts can be many to many, right? You could have many ways to describe the same concept, something that I came up against when I was doing some maths tutoring during my degree, how to describe what a logarithm is. I ended up using lots and lots of different examples to try and get it to click in the head of one of my students. Similarly, words and symbols that you use to communicate things could have multiple different meanings. The word run currently has about 600 and something definitions in the English language. So what I really want to get at with this part of the talk is to point out that when we communicate with other humans, because of that internal translation layer, we can never know for certain that what we've communicated is what we meant to communicate. The pink light bulb and the blue light bulb, you cannot compare them. You can never actually know. All we have is best guesses and approximations and some common vague shared understanding of langue, some shared language. And the less we have that shared context, the less able we are to communicate at all. Communication is really, really hard. So, another fun story about long-term nuclear waste, actually. How do we make sure that knowledge sticks around? This is a fun little tidbit. So one of the things that has been most consistent about human civilizations, as long as for thousands of years, is that we've hung out with these animals. And unlike dogs, which we have domesticated for a longer period of time, we haven't really changed how these animals behave that much. If you compare a wolf to like a chihuahua today, they're not recognizably the same thing, but we live with random bred cats, and we have done for a long time. It's reasonable to assume this would continue. So one person who's associated, I believe, with this Institute for Long-Term Nuclear Waste Storage said, okay, what if we genetically engineered some cats to glow in the presence of nuclear radiation? We can do that. I want one of these cats. Well, I'd like it if it didn't have to be in nuclear radiation to glow. I want a glow-in-the-dark cat so badly. But we can do that with modern technology. And he said, okay, we've now got some sort of visual identifier of the presence of ionizing radiation. How do we make sure that people know this is a bad thing? What sort of mechanisms can we use to convey meaning through time that stick around? And he thought music and folklore. And so he created a song called Don't Change Color, Kitty, which is intended to convey the idea that if your cat suddenly changes color, it's bad juju and you should get out of there. And combined with these genetically engineered cats, which we could expect to maybe stick around if enough of the population had that gene, enough of the cat population, apparently this song is so catchy that it will just live in your head rent-free for the rest of your life if you listen to it. So I haven't listened to it. But if you're brave, go away, listen to it, and tell me if it's good. After all, we know, it's common knowledge to us that music can be used to convey a specific cultural message, right? Like, gotcha. One last meme for the road. All right. So we come back to this model of communication. And this has all been very interesting, but I'm 20 minutes through a 45-minute-ish talk, and I haven't really talked about software. So this is how we talk to other people. And it's hard and it's messy, and all we have is best guesses. Fortunately, a lot of what we do is we talk to computers, and they're a lot easier. So what happens when you program computer is you have an idea in your head. Let's say I want to write FizzBuzz. And I write some code in order to try and convey that idea. And a computer operates on it. Now, computers have no sense of concepts and signifiers and all the things I've been talking about. So what we do is we build language for them. We start with machine code, and we add layers of syntax, syntactic sugar, and abstractions, layer upon layer, until we have something that can reasonably be called a language. We teach the computer what if and when and open curly braces mean, and we're able to communicate with a computer. But the thing about a computer is it has no interiority. If I've written some code, I can know that the code is running as I intend it. Very different to a human being. And a programming language, in the language of this talk, it's the rules for a language game. But just like with English and my household, we can make house rules for, let's say, Python. That's what code is. That's what, when you add a module to your software, you're adding a new rule to the language game. This is what I mean when I say user. This is what I mean when I say get data from S3 bucket, right? You add new words to your language. You add new rules to your language game. Yeah, writing software adds rules. So really a lot of what we do as programmers and people who build software is building language with which we can communicate with a computer. We can communicate concepts so that the computer can operate on them. And how well we're able to communicate those concepts, it depends on how well we build our languages. So this is actually getting towards a bit of a solved problem, right? Sitting at home, writing code, just you and your computer, right? This part is pretty much a solved problem. If I write some Python code and it's running in CPython, I can actually look at what that code is compiling to in terms of machine code. I can see exactly what that computer is doing. This is pretty much an understood, solved problem. This half of the diagram is get good at writing code. Practice your HackerRank stuff, your leak code, read all the Java for dummies or whatever. Incidentally, my one mention of AI in this talk, this is why prompt engineering is qualitatively different than writing code. Is because you've added a black box back into this side of the equation. And I think that's really interesting. If I do some prompt engineering and a computer does something as a result, I can't understand each granular step of what it's doing in the same way that I can if I write Python and I look at what it compiles to. I think that's really cool. So this is getting towards a solved problem. Great, we can all go home and play Baldur's Gate 3. Except this isn't what happens when you write software. What's actually happening is there's you, and there's your ideas, and you write code, and the computer operates on it. And then there's everyone else in your team who's doing the same thing. And you also have ways of talking to them, like meetings, water cooler chats, Jira tickets, documentation. And that long arrow across the bottom is often how we think about communicating with other people on our team. And that's the part where the things I've talked about so far, our signifiers and our concepts and our context, comes in really, really handy. But this channel across the top, where I'm writing code and it's going onto the computer, and someone else is writing code and it's going onto the computer, that is also a channel of communication, right? We use code as a tool of communication as well as meetings and Jira tickets and documentation. This is why things like clean code are important, is because when we write code, we're actually communicating about what it is we want the computer to do in the very precise language of, here's what I want the computer to do, which is code. This is our last philosopher of the talk, Paul Grice. He was a British philosopher of language. He was active, throughout the last century. He did a lot of really interesting things, but the part of his work that I'm interested in today is that he came up with something called the cooperative principle. And this is also known as Grice's maxims, if anyone's heard of those. And what he did was he looked at lots of systems of communication where people were communicating cooperatively. And what he meant by that was earnest good faith attempts to communicate concepts with each other in order to reach some shared mutual goal. Something like a sprint planning meeting. You're not joking, you're not lying, you have a shared goal, which is to come out of the sprint planning meeting with a set of things that you're going to do, and you need to communicate effectively, efficiently, and honestly in order to make that happen. So he observed lots of systems like this, and he came up with the cooperative principle, which was a description of behaviors that he saw replicated again and again. So these are descriptive things, although he phrased them in prescriptive ways. He said, oh, well, I notice people are doing this, but he's actually later phrased it as be this way. And his 4 maxims are these. You've got the maxim of quantity. When you're communicating cooperatively, you need to be as informative as is required, but not overly informative, right? You don't want to info dump everything about a given topic if someone has asked you a very specific question. Fairly obvious, right? You've got the maxim of truth. You only say things that you believe to be true or can actually know to be true. Obviously, having said you can never fully know what's in someone else's head, there's a bit of a caveat here, which is, yeah, things you can reasonably believe to be true. If somebody has told you that they have an opinion, you can't say, well, I can't possibly know someone else's interiority, so I won't say that. You can. And this is why lying does not come under cooperative communication. Also, a lot of jokes rely on misdirection, making somebody assume one thing and then revealing that that assumption was flawed. So the maxim of truth, you can't be doing that if you're communicating cooperatively. He also said the maxim of relevance. Don't include information you do not know to be relevant. So, for example, if we had René and Thomas playing their Lego game, and René said white, or René said block, rather, and Thomas handed him one of the blocks and one of the jumpers, that jumper wasn't relevant. That's not what that wouldn't have been communicating cooperatively, right? And it ties into the maxim of quantity, because obviously if you're being more informative than is required, you're probably being irrelevant too. The last one is, to me, the really interesting one, and that is the maxim of clarity. He said that when people are communicating cooperatively, they're not using language that is unnecessarily obscure. And I know I talk like a thesaurus, right? So I often break this one. This is the part of communication that requires empathy, and where the understanding of some of the concepts I've talked about today comes in really useful. You need to be able to have some idea of what's going to be understandable to your audience, the people with whom you're communicating, and you need to tailor the way that you communicate to fit that mental model of their interiority. And when I mentioned he framed all of these imperatively as things you should do, I love the maxim of clarity for this reason. So maxim of quantity, he said, be informative. Maxim of truth, be truthful. Maxim of relevance, be relevant. For the maxim of clarity, he didn't say be clear. He said be perspicuous. Has anyone ever heard that word before? Some people have, but I hadn't until I started researching this for the talk. I knew about his 4 maxims, I knew what they were, but be perspicuous. What a violation of the exact maxim that he's talking about. Perspicuous means clear, able to be seen through. So perspex, perspex glass, comes from the same root. So if you're ever doing like an icebreaker at work and you have to say something about yourself, just say, I'm perspicuous. It's great. So what about code? I was talking about code as a channel of communication between engineers on a software team. Now, each of these can correspond to some really nice clean code sort of ideas. Maximum of quantity, like make sure that you're including all the data that you need. Maximum of truth, check your assumptions, fail out gracefully. Maximum of relevance, factor out functions into small self-contained units that do one thing well. But the maximum of clarity is the one that I think is really, really interesting. If you're going to frame your communication to the computer in a way that the computer understands, in a way that you're trying to fit real-world problems onto the computer, and if you're going to communicate with the computer clearly about real-world problems, then it really helps if the language you've built up with your computer, the software that you've written, is able to describe those concepts clearly, with perspicuity, right? And that's domain-driven design. That's basically the ethos behind domain-driven design. Because, it does a lot of other things like clean, well-documented code for clarity of reading by other software engineers. But for clarity of reading by the computer operating on problems that you have given it, communicated clearly, that's domain-driven design. Because what's really happening when we build software, I've said that this is what's happening when we build software. That's not quite true. Because when we're on a team together, and we've got our Jira boards, and we've got our Kanban, we've got our sprint planning, whatever, and we've got good documentation, because we're all doing good clean code and documentation practices, right? This is also getting towards a solved problem. This is a paradigm that we know well. We actually do know how to work with other software engineers pretty well, software engineers, architects, other technical people. Communication between us is not actually, we have a lot of shared language about what it is that we're doing. We're able to communicate pretty well, actually. But that's not what's happening when we build software in a company. What's happening when we build software in a company is that we have stakeholders, people who pay our bills, and they have ideas in their heads. and they say something, they talk to a product manager, so on and so forth. On all hands, we're going to build AI into our project, whatever. And this turns into a communication to you, Jira tickets, things that you're operating on within your software team. That gives you an idea of what the computer needs to do, and you try and make the computer do it. This is what's happening when you build software. But what stakeholders think is what's happening when you build software is this. Stakeholder has an idea in their head, and they say something, and then the computer and software happens, right? We are an implementation detail in that process to them. We are a translation layer between the people who want that software to exist, to address real-world problems and probably make them a load of money, with the translation between those people and what the computer actually does. And our lives are made much easier if we have to do as little translation as possible. That's what domain-driven design is. It's taking the language and concepts directly from the stakeholders and using that context to build up the language with which we speak to our computers, which is the software we write on top of our programming languages. This is where the problem of, our users need to be able to change their gender happens. Because if your computer thinks about gender in a completely different way than your stakeholders do, you won't be able to communicate that concept to your computer. You have to strip down all of your house rules, which is the software you've built, go right back to the basics of your programming language, your framework, and start again with new concepts and new ways of the computer understanding aspects of your users' profiles. So that's what I meant when I said we can try and figure out how to avoid this expensive mistake. A lot of the most expensive mistakes in software are when we build the wrong thing, we make the wrong assumptions, we model the world incorrectly. And the better we're able to communicate with our stakeholders about what it is that they want and the way that they see the world, the better we're able to build up a language with our computer in which we're able to communicate those same things. And that is domain-driven design. So, in the language of the talk that I've just been giving you, what does this mean for us? It means wherever we can, we should be reusing context. It means that we have to do less work in translating things between different paradigms. It means that we can all play the same language game. This is where ideas like having stakeholders write behavior tests in languages like Gherkin or whatever comes from. The idea that the way that your stakeholders think about the world should be understandable to the computer system. I'm not going to comment on how well those kind of tests actually work in practice, but that's the underlying idea. We don't want to have to spend effort translating between what our stakeholders think about the world and what our computer software thinks about the world. Because in the worst case, we get something which is untranslatable, and that's when you have to strip right back and do a rewrite. We want our signifiers to match our concepts. We want the things that our computer thinks of, with the way that we say, like, I want to be able to change my gender. If what the computer thinks about gender is different than what the stakeholder thinks about gender, they've got two very different light bulbs going on. It's easier to find those things out when we're more specific about what we mean. And we really drill down to, okay, when you say gender, what do you mean? When you say, user, what do you mean? When you say run, which of its 600 meanings in English do you mean? Right, conclusions. Computers are awesome. We can talk to them in ways that we can't talk to people. We can know for a fact that when I wrote FizzBuzz and it ran on the computer, it was correct and the computer understood me. I think this is one of the things that people like, and you may not, people like me who, as a younger person, found it very hard to communicate. I'm giving you a talk on how to communicate. It's because I learned this from first principles, right? I think this is why we're drawn to programming often, is because you can have that feeling of, I managed to communicate something. I managed to get an idea out of my head and into the real world in a tangible way. People are a lot harder. Communication in general is hard, intrinsically, philosophically hard. I think we should all be proud of ourselves for managing to do it at all. We can get better at it. You can get better at it with rigorous thought, by developing empathy, which is a skill you can learn, and by thinking about what other people's context is and how they are going to turn signifiers that they hear into concepts in their head. Thank you so much for coming with me on this journey through linguistics, philosophy, computing.